Okay, so the idea is to do a simple and a quick example of how we can apply elementary congruences for a quadratic form to transform it from a quadratic form to a sum of squares. So this is our quadratic form. You can see this q, and this is all this expression, and now we want to transform it using elementary congruences to a sum of squares. So we start by defining the matrix that represent the quadratic form. You can see this is based on the coefficients of the values. You see it's here 2 for x squared, so here it's 2. Here it's xy 4, so it is divided by this one and that one. Together they are 4. For this y squared, this is here, so it's 2. For this xz, it's here 1 and 1, it's 2, and etc. So this is the matrix that represent this quadratic form. So you can represent the quadratic form in this case where this one is A. Now the next thing that we do, we want to use the elementary congruence to reduce the matrix to a diagonal form, which will represent the sum of squares. So everything that we do to the rows will be done to the columns the same way. For example, for the first row, we're doing, for the second row, we say that second row minus first row. We want to annihilate every element that is not in the diagonal, such that the matrix will become a diagonal. But everything we do to the rows will be done to the columns as well. So R2 minus R1, and so C2 minus C1. R3 minus half R1 will be done, it's exactly the same, C3 minus half C1. And if we are doing this, we will get to this one, still not the diagonal problem thing. So we continue and doing those, we will get to the diagonal form. And now this, if we translate it, we can translate it to a sum of square like this, and this is the quadratic form as a sum of squares. This is it. This is how we can use the elementary congruence to do it. And thank you very much. We transformed the quadratic form into a sum of squares.